You guys, yesterday, 6.3 introduced you to vectors, all right? How do you know, just by looking at notation of something, that something is a vector? Like, how do you know that U right here is a vector? Lowercase, it's short. It's not tall. I understand. It's lowercase and it's bold, right? What is very, very important about the notation on your vector, guys? It's pointy. You gotta have these pointy things on the outside. What a vector is it's a compilation, I guess I want to say, but of the end point and the beginning point, right? A vector is a directed line segment. So what the vector notation is here is it's your two y's and it's your two x's that are already combined. Right? You don't have to do the distance formula to find the magnitude. You just take each piece, square it, add it. We'll talk about that a little more from yesterday. How do you find the component form of a vector if you have 2 points?
You subtract the initial.
The other way? Terminal minus initial. That's real important. And then once you get that, then you have your vector. So today we're going to talk, and then you guys can add them, you can subtract them, you can multiply them. Today we're going to talk about something called the dot product. And I'm going to say this a gajillion times today, but here's how you find the dot product. First of all, this is what it looks like. Do you see the two vectors? You know that they're vectors because they're lowercase, they're bold. Do you see the dot that's in between them? That is a raised, bold dot. It is not a multiplication. If you want to multiply, they'll put like U times V or something like that. They will not put a dot in between. This is called the dot product. How do you find the dot product and what does that mean? First of all, the dot product, what does the word product mean? It's the answer to a multiplication, right? So your dot product is going to be a singular number. It's not going to be a vector. It's going to be a number. The way that you find the dot product, it says U1 times V1 plus U2 times V2. What I'm going to say a million times is first times first plus second times second. That's how you find the dot product. All right, this is kind of stuff we talked about, or you saw yesterday, to find magnitude and all that good stuff, how you find it, but we'll talk about that more later. Finding the dot product. This is what the problem would look like. First of all, the directions are going to say find the dot product. So you need to say to yourself, okay, I should have one answer. You're not adding these two together. It's not 4 plus 2, comma, 5 plus 3. That's not what this question says. This question says, what is the dot product? You're going to say, now write out what I'm doing, guys. I don't want just answers. You have to show how you got your answer. So for letter A, to find the dot product, it's first times first. So 4 times 2 plus second times second. 5 times 3. Everybody see that? Now we simplify. 4 times 2 is 8, plus 5 times 3 is 8 plus 15 is 23. Do you see how you have one singular value? When you are asked to find the dot product, you should get a number, not a vector. So look at B. Same thing. It's the dot product. So first times first. 2 times 1. See how I'm writing it down? Do that. Plus second times second. Negative 1 times 2. What's 2 times 1? 2. Plus, what's negative 1 times 2? Negative 2. What's 2 plus negative 2? 0. Okay? Do you think that means something? Yes, write this word down. Orthogonal. You want to know what it means? Orthogonal in physics is the same way as saying perpendicular. We'll talk about this a little more in a minute. But when the dot product of two vectors is 0, it means if you were to draw them, they would meet at a what? If it's perpendicular. 90-degree angle. Yep. All right, let's look at letter C. C says first times first. 0 times 4, right? Plus 3 times negative 2. What's 0 times 4? 0 plus negative 6. So what's your dot product? Negative 6. Questions?
Would we write 0 or diagonal for the answer?
Depends on what the question's asking. If it asks for the dot product, it'd be 0. If are these two vectors orthogonal, you would say yes, they're orthogonal. We'll talk more about that, just depending on how the question's asked.
Would this be enough work? Because like we're showing that we're putting the first together, even though we don't.
All right, whoa. Super easy, guys. All right, let's look at this. Let's write this out. First of all, where are you guys going to make mistakes? 1, you're going to confuse the order. 2, you'll forget a sign. 3, you forget to like multiply 2 negatives as a positive, something like that. There is nothing in this stuff that is just so hard for you to grasp the concept. It's just a matter of really and truly taking your time and paying attention. So letter A. Letter A says U dot product of V times what? W. So if I look at letter A, what is this asking? Before you just start, what is this asking to do? Find the dot product what? First, and then multiply that into vector W. Everybody understand that? So the first thing I'm going to do is write everything out. So U is negative 1, 3, dot product, 2 comma negative 4. Everybody agree? And then I'm going to multiply that into 1 comma negative 2. Order of operations, guys. The first part of this question says find the dot product first. And then remember, dot product is one singular value, right? Yes.
What does the little pointy thing mean? Like if it's pointy and then like curved?
That's the vector notation. You have to have that on your vector. Because if you don't, then it's telling me it's a point.
And that one's supposed to be pointy too, because it's like round.
What's supposed to be pointy?
Like the 1 by the 2, is that supposed to be round?
These are the vectors.
Oh, I thought it just looked.
It has to, if it's a vector, it has to be in points. Like that, like arrows. So to find the dot product, it's first times first. So negative 1 times 2 plus second times second. So 3 times negative 4. What is negative 1 times 2? Negative 2 minus 12. You guys agree? So the dot product is how much? Negative 14. Now you're going to multiply that into this vector. The hardest part here, guys, is just not messing up signs. There's nothing in here you guys can't handle. Nothing. It's just a matter of taking your time. So now we take negative 14 and we distribute. So what's negative 14 times 1? Negative 14. And then negative 14 times negative 2. Positive 28. And look at my notation. It's a vector. So you have to have your pointies. Question. Okay. Let's look at B. I'll do B right here, over here. What does B say?
Find the point dot product of the U times 2.
Okay, so think about this. Before you just jump into it, guys, this is dot product. It's not multiplication. You will never see a raised dot in these to say multiply. If you want to multiply, it's going to be stuck in front of a letter or a parenthesis. So the first thing I would do is I'm going to say, okay, U. What is U? U is negative 1, 3. Dot product, 2, and then what is V? 2, negative 4. Okay, Sophia brings up a good point, guys. If I have to guess if it's pointy or rounded, I'm going to guess rounded. So make sure you let me know, hey, these are points on the end of it, not rounded. So what do I do first, guys? Do I find the dot product or do I distribute? We're going to distribute first. So my negative 1, 3 is hanging out over here. And then I distribute. 2 times 2 is 4. 2 times negative 4 is negative 8. And now I find the dot product. How do we do that? First times first plus second times second. What's negative 1 times 4? Negative 4 plus, what's 3 times negative 8? Negative 24. When I add those two together, I get negative 28, a singular value. Good. Do you see the difference between those two questions? Letter A said find the dot product first, then multiply it into vector W. B said multiply into vector V first, then find the dot product. You guys have to understand parentheses in order of operations. All right, C. This is from yesterday. What is C asking you for? The magnitude. If it was one set of bars, it'd be absolute value. The double set means magnitude. Remind me again what magnitude is. It's the length. It's how long is this vector. So how do we do this? Well, you take vector U. U is what? -1, -3, or +3, sorry. And the magnitude formula is just the first part of the vector squared plus the second part of the vector squared. What's -1 squared? 1 plus 3 squared is? So square root of 10. If you can break it down, break it down. If you can't, leave it. Yes, sir. I don't know. We'll see. TBD. All right, this is why you would have to have a calculator. All right, the angle between two non-zero vectors. You guys are going to have to use your calculators for a minute. If you don't have one right now, it's not a big deal. It's just the last step of this problem. But this is what we're talking about. You're going to be given two vectors, a u and a v, and you're going to be finding the angle in between it. All right, the included angle. So you just understand what's going on. Here is the formula. And some of you guys are like, oh my gosh, guys. Let's talk about it for a second. First of all, what are you finding on the top? The dot product, okay, not bad. And then what are you finding on the bottom? The magnitude. And then what are you doing to those two magnitudes? You're multiplying them. And then what do you do to those two things together? Your calculator is going to divide them. Really? Not a big deal. What you need to understand, though, is are you finding the angle itself? No, you're finding the cosine of the angle. So what are you going to have to do in your calculator? Cosine -1. See? It's very easy, I promise. I promise. People are going to say, are we going to get this formula? I don't know if you are or not, but it's just dot product over magnitude, not that big of a deal. So let's talk about how we would do this problem. Oh my gosh, what are we going to do? Okay, let's just think about it for a second. First of all, the formula is the cosine of theta equals the dot product over the magnitudes, right? Okay, that was super hard. Now take your time, take your time, take your time. How do we find the dot product? I'm going to go through and I'm going to remind myself it's first times first, so 4 times 3. This is what I'm going to expect to see on your test. Plus second times second is 3 times 5. And then I'm going to go ahead and do the magnitudes. What's the magnitude of u? How would I figure it out? It's a square root of 4 squared plus 3 squared, right? Times the magnitude of 3 squared plus 5 squared. Okay, so look. If you show me this, I don't need to see anything else. Oh, hi. Okay, so now, if you guys show me this, I'm good. At this point, guys, this is do you know how to use your calculator? If you try to put all this in at one time, I guarantee it's not going to work out well for you. The best idea is to just simplify, even just a little bit. Let's simplify the numerator. What's 4 times 3? 12, and 3 times 5. So when I add 12 and 15, I get 27. Okay, that's easy enough, right? Then let's just do the bottom. You don't even have to do the square roots. Just simplify it. 4 times 4 is 16, right? And 3 times 3 is, so 16 plus 9 is, okay. And then here, 3 squared is 9 plus, gives me 34. Now, some of you are going to be like, well, you can simplify square root of 25. Okay, fine, do it. If you don't want to, don't worry about it. I'm going to say 27 over 5 square root of 34. Where'd I get the 5 from? Okay, so in my calculator, this is how I'm going to do it. I'm going to say 25. No, I'm not. I'm going to say 27 divided by parenthesis 5 times the square root of 34. Close your parenthesis. Why do you have to put it in parentheses?
So it doesn't think you're doing 27 over 5.
Correct, because the calculator will say, ooh, order of operations, divide 27 by 5, then multiply. You don't want to do that. Put this in parentheses. This is where you guys will make your biggest mistake. Not the whole math pre-calc behind it, but the calculator portion. So what decimal equivalent do you get? 92609? Okay, perfect. You should be getting that. If you're not, you did something wrong in the calculator, you're in the wrong mode, whatever. Is that the measure of the angle? No. So I hit second cosine. Yeah? And I get, how big is the angle?
22.17.
Theta is about 22.17 degrees. Good. All right, now on WebAssign, I think they might give you one where you got to work backwards or something like that, which is fine. We'll go over it a little tomorrow. WebAssign, you have to answer in WebAssign for 6.4, but you'll be fine. Almost. All right, now we're going to talk about when two vectors are orthogonal. Guys, what does orthogonal mean? We just talked about it. It means perpendicular. It means they meet at a 90-degree angle. We say orthogonal because vectors are in physics and orthogonal is in physics. So you are going to prove, I don't care that you can look at it and just see, you're going to prove that vectors are orthogonal or parallel. How would you prove this? All right, this is a super, super simple question. This question says, are these orthogonal? How do you find if they're orthogonal or not? You find the dot product. So I'm going to say first times first, 2 times 6, plus second times second, -3 times 4. Guys, what's 2 times 6? Plus -12. What is my answer? 0. What is the answer to this question? Yes. Yes. If all you do is just give me a big old yeah with no supporting work, you're going to get a big fat no from me, okay? You have to show me, yes, they're orthogonal, no, they're not. Question.
So when it's like that, orthogonal equals 0? Like
With the dot product. When the dot product equals 0, if the question is, are the vectors orthogonal, your answer is yes. If the question is, what's the dot product, you have to tell me that. Now, guys, what this would look like, look, if you graph this vector from the origin, vector u goes over 2. No. I just want to show you. Guys, it's just like graphing a line. The only thing that's different is there's a point or ray at the end. So 2, -3. So over 2, 1, 2, 3. Here is vector u. It goes like this, right? And then over 6. 1, 2, 3, 4, 5. Whoops. One more check mark. So 1, 2, 3, 4, 5, 6. And then up to 1, 2. There's vector v. Do you notice, if I drew this 100% correct, how would they meet? At a right angle. I mean, I did the best I could. And then, what is this? That's the angle in between, right? All right, so let's scoot a little bit here for a second. All right, one more thing, and then we're done. Two vectors that are perpendicular meet at a right angle. They're orthogonal. They're orthogonal if the dot product is 0. Okay, we've gone over that a few times. Everybody with me on that? What's the other option? If it's not perpendicular, could be parallel. This is how you know if two vectors are parallel. And you guys are like, what does that say? Guys, first goes with first, second goes with second, right? Do you see how the first u goes over the first v? The second u goes over the second v. You see that? If they're equal to each other, it's parallel. Okay, guys, this last slide is asking you to determine if the two vectors are parallel, orthogonal, or it could be neither. It could be none of them. Remember, orthogonal, the dot product would have to equal 0. So the dot product would equal 0, and that would show that they were met at a 90-degree angle. Parallel means that they never touch, and neither would be none of them. So first thing I would do here, because I don't like the way that this is written with our I's and our J's, I would go ahead and rewrite this as vector u is 2, -2, and vector v is -1, -1. Remember, if there's no number in front of the letter, you just assume it's a 1. So let's first check to see if these are parallel. So how do we check for parallel? You take the first over the first and set it equal to the second over the second. So simplify if you can. What I mean by that is 2 divided by negative 1 is still going to be just negative 2. And then negative 2 divided by negative 1 is going to be positive 2. So I look at this and I say, does negative 2 equal positive 2? No, it doesn't. So these vectors are not parallel. Okay, so let's try to see if they are orthogonal. So again, how do we find if they're orthogonal? Their dot product would be 0. So let's check for orthogonal. So my dot product would be first times first plus second times second. So negative 2 times negative 1. 2 times negative 1 is negative 2 plus negative 2 times negative 1 is positive 2. When I add negative 2 and positive 2, I get 0. So algebraically, mathematically, what did we just prove? We proved that these two vectors were orthogonal because their dot product is 0. They're orthogonal. How would I show that graphically? Well, real quick, if I just graph this. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. Okay. My first vector u, we're going to go over 2 and down 2. Draw it, put my little arrow. This is u. And then I have vector v is negative 1, negative 1. Here, draw it. And you notice here, this meets at the world's tiniest right angle right there. So there you've proven that these two vectors are orthogonal.